In January 2022, a volcano eruption happened in the Tonga Islands that forever changed the way we understand GPS signals. This volcano caused a massive disturbance, sending out a colossal mix of gas and debris in the air. It generated a shockwave that traveled across the entire atmosphere, reaching all the way to Alaska, and launched a tsunami over nearby islands. Over northern Australia, it crafted a weird plasma bubble in the upper atmosphere, which disrupted GPS systems for hours. People that happened to be under this bubble and in need of precise GPS waited for ages before their device could receive precious information again. The exact place where these disturbances occurred is called the ionosphere. It's the place where our atmosphere meets outer space and looks like this buzzing layer where heat from the sun turns gases into electrically charged particles. It can also be seriously unpredictable, changing depending on the weather and thinning out when the sun's rays are less powerful. Because it's electrically charged, the ionosphere helps us with our communication needs. It houses many satellites, including the International Space Station. Here's how changes in the ionosphere can interact with GPS signals. Let's say you're playing detective with your friends and need to find them using a special radar. This radar sends out invisible waves through the ionosphere to locate your buddies. If everything is normal, you'll find their precise location in no time. Should those waves go through a place where the ionosphere particles are a bit messed up, the waves might slow down, get scattered, or change direction, confusing your radar. In the same way, when GPS signals travel through a damaged ionosphere, they can malfunction. Scientists have developed a way to fix this, like special sensors to anticipate changes in the atmosphere. The ionosphere is also sensitive to rockets being launched from Earth, not just storms and volcanoes. At first, astronomers believed these red patches they were noticing in the sky were similar to the northern lights found in Sweden, Finland, or Canada. But they soon figured out there were gaps in the ionosphere. Beautiful to look at, yes, but experts are worried that these crimson areas might be causing communication and astronomy problems that we've yet to discover. Since scientists don't know all the effects of these holes on our environment, it's best to steer clear if you see a red hole in the sky, just to be safe. But at least they seal up within 10 to 20 minutes. Mars has its own eerie set of lights happening in the atmosphere, and you'd think, since it's the red planet, these lights would also be red. Should you ever land on its surface, surprise! At times, the sky turns to a green glow. This unexpected hue could be very important for future Mars trips, since it can help specialists better understand the Martian atmosphere. Or what's left of it. That's because at some point in its history, Mars switched from being a warm and wet world to the cold, dry plains we know today. How is Mars slowly losing even what's left of its atmosphere? One popular theory is that Mars's weak gravity, combined with the fact that it doesn't have a strong magnetic field, lets the atmosphere escape into space. This vulnerability comes from the solar wind, a constant flow of particles from the sun. The sun's push over millions of years may have thinned out the atmosphere, grabbing the lighter parts. Some scientists suggest another possibility. A colossal impact by another object might have swiped Mars's atmosphere away. Studying this greenish glow is key to understanding what's going on the Martian atmosphere, a place satellites can't directly explore. Since we plan to visit this neighboring planet in the following decades, scientists intend to develop the perfect spacecraft. Knowing its atmospheric density helps us build machines tough enough to handle Martian drag, and we can design parachutes that gracefully descend to the Martian surface. See these amazing purples and greens lighting up the sky? That's not your typical aurora. It's Steve. First discovered by regular people, not scientists, some years back. We now know it's the aurora's more elusive cousin. Steve is short for Strong Thermal Emission Velocity Enhancement and was caught on camera back in 2018 by a bunch of amateur aurora chasers in Canada. They then brought it to the attention of NASA scientists. Here's how this is different from the aurora, starting with the appearance. Steve is more of a magenta streak, while the aurora is usually made out of green ribbons. Auroras happen when particles from the sun interact with the Earth's magnetic field and atmosphere, causing gases to emit light. Steve is thought to be a separate optical phenomenon that sometimes appears alongside auroras. While the exact mechanism behind it is still being studied, scientists believe it is linked with charged particles in the ionosphere that also interact with the Earth's magnetic field. Now that we know where to look, Steve might not be as rare. If you're planning to catch a glimpse of it, you'll need to travel to places where auroras usually happen, like Canada, Alaska, Northern Europe, New Zealand, and Australia. That's because it's never visible on its own. It's powered up when the aurora is extra bright during geomagnetic storms. Auroras can also happen on the sun too. These luxurious lights happen somewhere around 25,000 miles above a sunspot, a dark magnetic patch on the sun's surface. Astronomers have only recently discovered our own sun is capable of generating these lights. So far, they've only spotted aurora-like signals from faraway stars. Here on Earth, the aurora can last anywhere from 15 to 30 minutes, maybe even a couple of hours if you're lucky. On the surface of the sun, though, this phenomenon is a week-long display of intricate lights. Strange lights in the sky can also happen before an earthquake hits. Mexico had its share in 2017, lighting up the internet with pictures of weird celestial shades before a massive magnitude 8.1 earthquake. Some voices in the scientific community wonder if this light phenomenon is indeed connected to earthquakes at all. Others have this theory that such lights are caused by the release of ionized oxygen from the breaking of certain rocks. A photographer from Finland captured these shots of a circular rainbow display in the sky and wondered what might be causing it. It's something pretty ordinary: pollen. These colorful rings are called pollen coronas, and they happen when sunlight hits the pollen in the air at a certain angle. You can easily tell if you're looking at pollen coronas if they're accompanied by star-like sparkles. Those are individual pollen grains, and they come in many sizes. The process is very simple. Sunlight hits the pollen and scatters into different colors. Some colors get blocked or crash into each other, creating a pattern known as diffraction. The pollen in these images is from pine trees, and under a microscope, they look like tiny Mickey Mouses. Those ears are actually air pockets that help them float in the wind. The air sacs all line up in the same direction, creating the elliptical shape of the rings. For these coronas to show up, pollen levels need to be very high. An astronaut up on the International Space Station once snapped this picture of our planet, showing these two weird blue patches of light in our atmosphere. They might seem related to each other, but these lights are two different natural phenomena that just happen to be captured at the same time. The first one down at the bottom is a massive lightning strike that zapped somewhere in the Gulf of Thailand. Lightning is usually pretty hard to spot from way up there because of clouds, but this time it struck between them, firing up the walls around it like a luminous ring. The second blue blob up in the top right happened because of the moon. The way our natural satellite lines up with the space station lets the sunlight it reflects shoot straight through Earth's atmosphere. This turns it into a bright light with a fuzzy halo. It happens because some of the moonlight bounces off tiny particles in our atmosphere, making the moon look blue in this picture. That orange halo curving along Earth's edge is just the atmosphere.
That's it for today. So hey, if you pacified your curiosity, then give the video a like and share it with your friends. Or if you want more, just click on these videos and stay on the bright side.